Hello, everyone. Welcome to Con 304. This is a deep dive on Amazon Elastic Kubernetes service. My name is Mike Stefaniak. I am a senior product manager on the EKS team. So we'll start with what is Amazon EKS. I'm sure many of you, are either using EKS or trying it out, but let's just cover the basics. EKS is our managed Kubernetes service at AWS, and it provides the flexibility of Kubernetes with the security and resiliency of being an AWS managed service. Some of the important things we think about for EKS is first, EKS is just vanilla upstream Kubernetes. We don't fork it in any way. The only occasional thing we do is backport security patches because we support versions for longer than upstream does. But otherwise, if you're running open source Kubernetes, you're going to get the same versions if you're running EKS. We do a lot of work to give a performant, reliable, secure experience. And really our goal with EKS is to make Kubernetes operations, administration, and management simple. So before we jump more into EKS, I think we need to talk about Kubernetes itself. What problems is Kubernetes solving? Why did AWS even build a managed Kubernetes service in the first place? And really, Kubernetes simplifies the deployment and management of containerized applications. It's also backed by a vibrant and active community and part of the Cloud Native Computing Foundation. One of the more common reasons you hear about moving to Kubernetes is portability, the fact that you can run Kubernetes across multiple environments. But that's actually not the top reason we hear from customers and yourselves why. It's really actually the faster deployment time. By moving to Kubernetes, your organization can move faster, deploy and ship code faster. And it's really the declarative self-healing nature of Kubernetes that provides those benefits and allow operations teams to sleep more soundly at night, knowing that they don't have to wake up or deal with problems deploying applications. Some of the other reasons are scalability. It's easy to run lots of applications in Kubernetes as well as availability. So then why Amazon EKS? Why did we build EKS? And really it comes down to, at a certain scale, running and self-managing Kubernetes adds significant operational overhead, which is that classic undifferentiated heavy lifting, and it takes time and resources away from core business applications. And so this was really the first reason why we built EKS is to take away that heavy lifting. First, the running and scaling Kubernetes is challenging. The other part is securing Kubernetes can be a lot of work for organizations, and that's something that you offload to EKS. And then the other major part with EKS is that we spend a lot of time making sure Kubernetes on AWS is integrated with other AWS services securely and reliably. All right, so many of you maybe are using EKS today. Others of you might be new to Kubernetes, and yet another group, you might be self-managing Kubernetes yourself on EC2, and possibly because you were using Kubernetes before EKS launched 3.5 years ago now. And here are some of the tips and some of the reasons why customers or that helps customers move from self-managed Kubernetes to EKS. The first thing to keep in mind is you're going to want to make sure you qualify your applications on a recent version of Kubernetes. EKS typically supports the most recent 4 versions of Kubernetes, and if you're self-managing, you may be on an older version. You're going to have to upgrade and qualify your applications on a version that's supported by EKS. The next is evaluating your user authentication process. We'll talk about that a little later on in the presentation. Then, as far as building out clusters, you may have some custom tooling today to manage your clusters. Maybe you're using the open source COPS project. When moving to EKS, you're going to have to evaluate moving to a different tooling choice, whether that's CloudFormation or open source tools like Terraform or Pulumi. You're going to need to adopt different tooling to deploy your clusters. You're going to want to perform load testing. We'll go into more details on how EKS can scale to support your applications. Then you'll have to figure out how to move your applications from one cluster on your self-managed Kubernetes over to EKS. One option is the more traditional backup and restore, taking a backup of everything you're running in your self-managed cluster and moving it to EKS. But more simply, we see customers be successful by simply just redirecting their CI/CD pipelines over to the new clusters on EKS. And the beauty of Kubernetes is if it's running on self-managed Kubernetes, you really shouldn't have to make too many changes to get it working on EKS. And then the final step is going to be shifting over application traffic. So you can see in the diagram on the right, this is a typical pattern we see customers making, where they'll use Route 53 weighted DNS to slowly shift over traffic from the clusters running on EKS to from clusters running on self-managed Kubernetes to EKS. And then before we get into more of the details here, I want to quickly touch on the tenets of EKS. What are the guiding principles that we keep in mind when we make decisions? So our mission is to bring you Kubernetes you want while delivering better efficiency with less overhead. And that's with applying our security, operations, scaling expertise. From the beginning, EKS was built as a production-ready service, and we support production workloads from a variety of industries and startups all the way to large enterprises. We also, as I mentioned, work closely with other AWS services to make integrations with Kubernetes as smooth as possible. And then, of course, we engage with open source projects. And really, open source is one of our favorite ways to collaborate with you. So moving from these tenets into the 5 areas we're going to talk about today. So we're going to talk about security, reliability, efficiency, cluster operations, and portability. And as a product manager, one of my jobs really is to answer questions. I get a lot of questions, whether it's from customers like yourselves on GitHub or in the AWS forums, or from the AWS solutions architects and account managers. There's lots of questions on how to do this or how to do that with EKS in Kubernetes. And so for the rest of this presentation, we're just going to cover a lot of the questions that I commonly get, and we're going to go over some of the a lot of the areas in EKS, and especially in these 5 categories. Okay, starting with security. It's no accident that security is the first section of this presentation. It's really the #1 feature of EKS. It's the thing that's going to get prioritized over everything else, and it's really the area where we spend the most time. So how do I secure my cluster? This is a rather broad question that I get, and I think it's important to talk about the shared responsibility model before we can really answer this question. So if you look at the diagram here, you can see the orange and the blue. And by moving to EKS, everything in orange is the responsibility of the Elastic Kubernetes service. So the control plane runs in EKS-owned accounts. We are responsible for the security of the API server, the scheduler, the controller manager, as well as the etcd instances that are backing your cluster. And then if you move to Fargate, which again we'll talk a little bit about in this presentation, even more of that responsibility shifts to EKS. So some of the worker node sides, such as the operating system kubelet, also moves into the EKS side of the shared responsibility. On your side is everything in blue. So things like worker nodes, policies, how you're configuring your cluster and deploying your applications are the areas that you need to concern yourself with when thinking about security. And a lot of the rest of this presentation, I'll be referring back to the shared responsibility model. How do I secure sensitive cluster data? One quick area to address is for the control plane side. EKS is part of the Kubernetes Product Security Committee that's responsible for triaging issues. And so most of the time, when there's a security issue upstream, we're going to be part of that inner circle that's responsible for addressing it, rolling out the fix, and your cluster is going to be patched before the before the issue is publicly released. So that's really one of the main benefits you get of EKS. But then it comes to the data on your side, at data actually running in the cluster. And so there's a couple of features I want to highlight here that we've seen customers use to protect sensitive cluster data, such as Kubernetes secrets. The first option, which we strongly recommend you do, is to encrypt your secrets using a AWS key management service. This was a feature we launched at least a year ago now, and it gives you the option to add an extra layer of encryption onto Kubernetes secrets. EKS already runs the etcd volumes that are encrypted and stored at rest, but this gives you an option to add an extra layer of encryption and defense in depth. Another feature, and this was another recent launch that we worked closely with the AWS Secrets Manager team, is now you have the ability to store secrets outside of the cluster in our managed Secrets Manager service. And then using the Secrets Manager CSI driver, you can retrieve your secrets. And one of the benefits here is that with Secrets Manager, you can have IAM policies that really restrict down which applications running in your cluster can access which secrets. And then finally, this is a very recent launch, another one where we worked with the AWS Certificate Manager team, is through their private certificate authority, you can now use the Cert Manager plugin for AWS Cert Manager Private CA to generate TLS certificates to provide secure authentication and encryption over TLS. So I think you can see a theme here that we spend quite a bit of time working with AWS service teams, especially security focused teams, on how we can use some of their managed services to provide a more secure experience in EKS. How do I limit access to the cluster endpoint? This is a pretty common question when you're getting started with EKS. By default, when you create a cluster, we give you an endpoint that's publicly accessible. And this is good for getting started and trying things out, but it's generally not a best practice for running your cluster in production. And so we also give you the option to enable a private endpoint for your cluster. And this endpoint is only accessible within the VPC of your cluster. If possible, we recommend you disable the public endpoint and only use the private endpoint. And if you can see in the diagram, when you enable this private endpoint, all of the traffic is going to go through the ENI that enables the communication between the subnets in your VPC and then the subnets in the EKS owned VPC where the control plane running. If you can't disable the public endpoint, then we have a feature where you can restrict using IP address CIDR ranges which addresses can access the public endpoint. So for example, if you have corporate networks from different offices, and those are the places where your users need to access the cluster, then you can just restrict the public endpoint to those ranges. The last thing I'll call out is for some of our most security conscious customers, if you don't have a need for any inbound or outbound internet communication, you can run clusters in private only subnets. And we have documentation on this. You'll have to set up all of the AWS private link for several AWS services like S3, ECR. But once you set all those up, you can run your cluster in a totally private VPC without any internet access. Okay, on to worker nodes. How do I run secure worker nodes? There's a lot we could cover here. Probably the easiest way to secure your worker nodes is to use an operating system that is built for containers. And the one I'm going to talk about here is AWS BottleRocket, which is the AWS supported host operating system that's optimized to run containers. And it's an open source project, and we publish EKS optimized variants of BottleRocket for each version of Kubernetes. I'd also like to shout out that we just launched native managed node group support for BottleRocket. So it's easier than ever to launch worker nodes in your cluster using a container optimized operating system. The next tip would be to treat worker nodes as immutable. So once you, just like containers are immutable, in that once you publish your container, you're not going to change it. You should treat worker nodes the same way. So if you need to update the AMI version of your worker nodes, rather than changing it in place, you just bring down, spin up a new EC2 instance, bring down the old one, and the new one has the updated AMI version. And again, if you're using managed node groups, all of this is automated. It's just a single API call. Next, it's strongly recommended to use AWS Systems Manager instead of SSH. Both the EKS optimized Amazon Linux AMIs and the BottleRocket AMIs include SSM by default. There's no need to open port 22 or enable SSH keys on the instance. If you need to access the instance for debugging reasons, you can go through SSM. EKS supports custom AMIs. While we do publish our own AMIs, we also open source the build scripts, and many of our customers have requirements or compliance reasons that they need to build their own custom AMIs. And if you do that, then we recommend using the EKS CIS benchmark, which we published a little over a year ago to validate that the custom AMIs you've built are following best practices. Finally, if you don't want to deal with any of this, if this sounds like a lot of work to you and you don't have specific security or compliance reasons, you can pass off this responsibility to Fargate. EKS supports Fargate, which is the serverless container engine for AWS. And if you saw in the shared responsibility slide earlier, that becomes our responsibility to maintain secure worker nodes. Okay, from worker nodes down to the pod level. When migrating from a world where you're deploying applications to VMs, this is one area that we see customers needing some help on, is how do you implement security at the pod level? By default, you can give your worker node an IAM role like you might do in a previous world where you're deploying applications to virtual machines. The problem is if you have multiple pods that land on the same node, they're all going to assume the IAM permissions of the worker node role, which violates that principle of least security. And so the recommendation here is using IAM roles for service accounts, where instead of giving pods permissions to the worker node role, you instead create a role, assign it specifically to a Kubernetes service account in namespace, in cluster, and then when you launch the pod, you just have to add a simple annotation to the service account, and the pod will pick up the IAM role of the role you created for the pod instead of the worker node role. Now, when you do that, the pod will still be able to assume the privileges of the worker node role, where in this case, you might only have very limited policies associated with the node role, such as ECR read-only access. But as an even more secure principle, you can totally block access to the instance metadata service, and then the pod can't assume any permissions of the worker node IAM role. That's at the authorization layer. You can take it a step further and do security at the networking layer. So you can use Kubernetes network policies to restrict traffic within the cluster. And then you can also use the feature of EKS where you can associate pods with specific security groups. And in this case, one of the common reasons we see customers doing that, if they have pods that need to access AWS services such as RDS or Elasticache, you'll assign the pod to a security group that can access that service, but then the other pods on the node won't be able to access that. So there's a defense in depth layer here where as a minimum, you should do security at the pod level at the authorization layer and IAM layer. And then as a defense in depth step, you can do it at the networking layer as well. Okay, what are some additional security best practices? It's important to point out here that Kubernetes is a single tenant orchestrator. It was designed for use cases where tenants within the cluster are trusted. If you have untrusted tenants, for example, you're running a SaaS platform and you have various customers that need to be deployed into your Kubernetes, the recommendation is to use separate clusters because namespaces are not a hard security boundary. However, if you have trusted tenants, for example, team A, team B within your organization, then these are some practices to follow. So using Kubernetes RBAC and namespaces to isolate tenants, using Kubernetes quotas and ranges, which will help control the consumption of compute resources. So say you want to prevent team A or application A from consuming the entire EC2 instance vCPU, you can implement limits and ranges as an administrator. A feature that was launched in Kubernetes version 1.20 is API priority and fairness. So if you have pods running in the cluster that need to talk to the API server, for example, controllers you've written, or add-ons you're running that need to talk to the API server, you can use priority and fairness to limit the amount of requests that can be made to the API server. Another good practice is enforcing policies to limit what dev teams can run in the cluster. As a good example, say you want to prevent teams from running host networking pods. You can use tools like Gatekeeper, where it's with policies built on Open Policy Agent, and limit what teams can run. And then again, down at the networking layer, you can use Kubernetes network policies. A good practice we see is default policies to deny cross namespace traffic and only enable it where you need it. For example, if application A has a dependency on application B, then after the deny policy, you can add an additional policy to allow traffic between them. And then again, I'll mention Fargate. As a defense in depth step, you can use VM level isolation where each Fargate pod runs in its own virtual machine. And this helps, but again, it's important to point out, if you have untrusted tenants, the strong recommendation is to use separate clusters. We know many of you operate in regulated industries, and one of the main benefits of adopting EKS is that many of these compliance standards that you need to meet are already done for you. So one to call out here is FedRAMP. We just achieved FedRAMP High earlier this year, and this just makes it much easier to run your applications in environments with these strict security requirements. And we're always working on additional ones. This is not an exhaustive list. There's ones from Europe that aren't shown here. All of this is in the EKS documentation. Okay. After security, the second most important feature of EKS is reliability. And we'll cover a couple areas here of how EKS ensures a highly available service, as well as practices you can take to ensure reliability and high availability of your applications. How does EKS ensure high availability? This is a question I get a lot. And if you look at the diagram on the right, this is all of the work we do to ensure that the Kubernetes endpoint you get when you create a cluster is going to be able to respond across all kinds of situations. So we run the control plane across 3 availability zones. The etcd instances are spread out across those 3 availability zones, and there's exactly 3 etcd instances to meet the quorum required for etcd. And then we run at least 2 API servers across those availability zones. All of it is fronted by a network load balancer. And this architecture is designed to eliminate any single point of failure that may compromise the availability and durability of the Kubernetes control plane. One of the main areas that we test a lot is being able to survive single AZ events. If there's an issue in AZ of a region, your cluster will still be available. We do rolling control plane upgrades. So if you do an upgrade, say from 119 to 120, it's done in a rolling fashion where new instances are brought up, old instances are brought down. And as long as your clients, which most of them are configured to reconnect in case there's an IP address change, again, the endpoint is going to always be available, even if it's undergoing an upgrade. We take automated snapshots in etcd in case something does go wrong. We have the ability to restore it and have automated processes to do so. All of this architecture and availability leads to the 99.95 SLA. This is a guarantee. This is not a best effort. It's something we take very seriously. And then as the last line of defense, rarely are you going to encounter an issue, but if you do, we have 24/7, 365 support with the EKS engineering team who can, who is works on hundreds of thousands of clusters and has seen every issue possible. And if something happens to go wrong in your cluster, we're always here to help. Can EKS handle the scale of my applications? Yes, but it's a shared responsibility. On our side, we auto scale on the control plane. So if you have additional, we look at a bunch of different signals to decide whether to scale your control plane. And we're much more aggressive scaling up than we are scaling down. And so we're going to auto scale to larger EC2 instances if we see you have an increased load on your cluster. We also will auto tune various Kubernetes control plane parameters such as QPS, max requests in flight, as those instances go up and down. So we want to make sure that when you're running on a larger instance, the software is configured to take advantage of all of the available computing power on the larger hardware. And then, running EKS, we get to take advantage of all the latest AWS infrastructure enhancements, whether it's newer EBS volumes or the latest generation EC2 instances, or the networking load balancer enhancements. We're always working to validate the new infrastructure enhancements that come out of AWS. So even in an existing cluster, you're going to see better performance without having to do anything. That's just something we're always working on enhancing behind the scenes. And we have a team right now dedicated to testing what we're calling mega clusters, really, really large clusters with up to 15,000 worker nodes. And this isn't forking Kubernetes. We're not changing anything. It's just taking advantage of the AWS scale and hardware and Kubernetes settings and pushing Kubernetes to its limit. Now your side. There's a limit on what Kubernetes can handle. If you have some runaway controller in your cluster that's creating 10,000 secrets or a ton of pods without cleaning them up, at a certain point we can't scale. Like there's no size of instances going to be able to handle that scale. So there's definitely things to monitor on your side. We expose metrics of the control plane where you can look at things like API server request latency. You can also, we recommend enabling the control plane audit log, where again, this is forwarded to CloudWatch. You can run queries to identify top callers. So you might see, one of the best troubleshooting tips we give and we do when any support cases are opened is looking at these top callers, and almost very quickly you'll identify some misconfigured controller or application that is misbehaving, and it's quick to identify and fix. And then we recommend visualizing these metrics, whether it's through CloudWatch, which supports Prometheus metrics, or Grafana, whether you're self-managing Grafana or you can now use the recently launched Amazon Managed Grafana service. Okay, on to efficiency. One question I get a lot: how do I right-size compute capacity? This is really, if done right, this is one of the major benefits of Kubernetes, is being able to make the best possible trade-off of cost versus performance. When it comes to right-sizing compute, this is the business decision you're always going to have to look at. It's how close to the edge of the required compute capacity versus a buffer that I may need to have for some scaling event. And some recommendations here for right-sizing capacity. One is you're going to want to set requests and limits as close as possible to actual utilization on your Kubernetes pods. And two of the ways you can do this is using the vertical pod autoscaler, which will help you scale your pod size up and down vertically. And then the horizontal pod autoscaler, which can help you scale out the number of replicas. Once you've right-sized a pod vertically, then you're going to have to scale out horizontally. And so using HPA and VPA are strongly recommended. Then it comes to actually compute capacity in your cluster. You need worker nodes or Fargate nodes to actually run the containers. And there's a couple different available solutions here. The most commonly used one is Cluster Autoscaler. It's the de facto autoscaling solution in Kubernetes. It'll take a look at any pending pods, ones that can't be scheduled because there isn't enough capacity, and it'll spin up additional instances in autoscaling groups. We also have a new project that we've been working on over the last year called Carpenter, which is our take on reimagined node auto-scaling in Kubernetes. So it's a different paradigm compared to cluster autoscaler. And and then the other option you have is AWS Fargate, where you can totally take away the need to scale capacity at all, because with AWS Fargate, it's our responsibility. We're going to scale capacity behind the scenes. All you have to do is schedule your pod to Fargate, and we will find the capacity for you. Okay, next up is reducing costs. Right-sizing compute that we just talked about is one good way to reduce costs. And if you look at the graph on the right, this was from a case study we published earlier this year of a customer's cost optimization journey. And auto-scaling and right-sizing were the first steps taken and provided a lot of bang for the buck. But then different purchase options that AWS has will also help you save cost. So using spot instances is a great way. You can save up to 90% off the on-demand pricing. Using managed node groups is strongly recommended with Spot because the Spot interruption notices are automatically handled by managed node groups. I mentioned cluster autoscaler last slide. There's different settings in cluster autoscaler, so you can use the expander mode, the priority mode, and prioritize lower cost node groups as opposed to on-demand node groups. Savings plan is another good way we've seen customers save costs. This works for both EC2 and Fargate. Moving to the latest generation EC2 instances, the 6th generation Intel instances were just launched. Graviton instances, you can save even more, up to 40% compared to the traditional instances. And then lastly, again, another mention of Carpenter, which is one of the areas where Carpenter works really well is if you're running really large clusters and you want to scale really fast without over provisioning a lot of capacity. This is an area where we've seen some customers get early success with Carpenter. Okay, scaling applications in clusters with limited VPC IPv4 space. The way the default networking plugin in EKS works, the VPC CNI, is it uses real IP addresses from your VPC as compared to other CNIs which may build an overlay network. And this has a lot of benefits. By directly using the VPC, it's easier to troubleshoot, you get better performance. But one of the issues you might run into is you're running in a VPC that has limited IP address space. And so what we've always said is the best solution to IPv4 exhaustion is IPv6. So this is now supported in EKS. Instead of giving a pod a v4 address, you can give a pod a globally routed IPv6 address. Every node gets a /80 chunk of IPv6 addresses, so you get pods that launch faster. We also support egress IPv4 traffic with IPv6 clusters, so it lets you migrate without have to waiting on the rest of your organization to already support IPv6. If you're still in IPv4 and you can't move to IPv6 yet, we have another solution called VPC CNI Custom Networking. In here, you can add additional CIDR blocks to your additional IPv4 CIDR blocks to your VPC, and you can run pods and subnets from those CIDR blocks while your worker nodes can stay in the primary CIDR block subnets. This is a fun topic and comes up a lot. Should I run lots of small clusters or fewer large clusters? The answer is it depends. At a minimum, we recommend that you run separate clusters per environment. So if you have dev, staging, prod environments, you certainly want to run different clusters there. The next is you're going to have to look at your constraints. The first one to look at is untrusted tenants. If you remember back to the best practices slide, if you have untrusted tenants, you're going to want to separate those out per cluster. The next thing we see customers look at is organizational boundaries. Sometimes it's just too difficult to manage teams in different organizations and try to have them run in the same cluster. So in that case, you're going to do separate clusters. Once you look at those constraints, then you're going to want to optimize within them. So the fewer clusters you can run, the more efficient bin packing you'll get and more efficient utilization of EC2 resources. So really it comes down to split when you have to based on constraints, but within those constraints, run as few amount of clusters as you can. Okay, moving on to cluster operations. How do I upgrade my cluster? One of the main benefits you get from moving to EKS is that we handle that for you. It's just a single API call to say upgrade from say 1.19 to 1.20. Really, the more managed features of EKS you can use, such as the managed data plane like node groups and Fargate, as well as EKS add-ons, which we recently launched, simplifies that upgrade process. EKS aims to be around 100 to 150 days behind upstream Kubernetes. We do a lot of work to validate and qualify each Kubernetes version and make sure it passes our application security bar. So at a minimum, you're going to have to plan for a Kubernetes version upgrade at least yearly. And if you do it yearly, you're going to have to jump multiple versions at a time. If you want to go one version at a time, you're going to have to plan for about 2 to 3 times a year. It's just a part of adopting Kubernetes. You're going to need to upgrade versions. And the reason our policy is that way is because of security. The newer Kubernetes versions have security patches applied. Old ones are much harder to patch. So use EKS managed capabilities when you can. Test, run the upgrade process in your test environments. Test your application manifests against deprecated or removed APIs. And if there's a version that's coming out that happens to remove any Kubernetes APIs, we will call that out in very bold text in our release notes. So I strongly recommend you look at the release notes before doing any kind of upgrade. Managing user access. We have 2 options here. You can either use IAM users, and with IAM, there's no need to maintain any kind of separate data store. You can use your existing IAM roles and users for providing user access to the cluster. If you have lots of users and they all need to get the same permissions, the recommendation is to just create a single role, give that access to the cluster, and then have the users assume those roles. The other option is OIDC, OpenID Connect. Many of you told us that you had existing identity management systems and it would be much easier to just integrate that into your cluster rather than having to give your users all IAM access. And so EKS now supports OIDC. You can use this as an alternative or an addition to IAM roles. And these are your options for authenticating users to the cluster. Once they're authenticated, to actually give them permissions to the various resources within Kubernetes, that's where you're going to use role-based access control. Monitoring, observability. This is an important part. How do I monitor the state of my cluster? Is a question I get quite a bit. And again, going back to that shared responsibility side, there's the control plane side, and then there's the application side. On the control plane side, you're going to want to enable control plane logging. So you get logs for components like the API server, the authenticator, the audit log, and all those get forwarded onto CloudWatch. And I believe I mentioned this earlier, but you can also scrape the Prometheus metrics that we expose through the control plane and monitor those. On the application side, EKS add-ons now in preview has support for the AWS distro for OpenTelemetry. We have an entire team in AWS that's dedicated to working on the OpenTelemetry project. We think it's the future of observability in containers. Today, OpenTelemetry supports metrics and traces, and you can send those off to many destinations, whether it's CloudWatch, Amazon Managed Service for Prometheus, or any partner destinations. For logging, we have the AWS distro for FluentBits, and if you're using Fargate, that already comes built in. You don't have to install anything. And as a separate option, if you just want an out-of-the-box, all batteries included, we have CloudWatch Container Insights, which you can install, which handles logging, metrics, traces, and is an all-in-one package solution that a lot of our customers have used. How do I route traffic to my cluster? The recommendation here is to use the AWS Load Balancer controller. So previously, if you wanted to expose a service in your cluster, you could use the in-tree controller, but that is deprecated. With the out-of-tree controller, we can move much faster and release new versions without having to be tied to the Kubernetes version release cycle. So with the load balancer controller, you can provision application load balancers in response to Kubernetes ingress objects, or you can provision network load balancers in response to Kubernetes service options. One of the more powerful features of the AWS load balancer controller combined with the VPC CNI is direct to pod routing. So you can skip the extra hop where you have to hit the worker node and have kubeproxy forward it to the right pod. Instead, you can just go directly from the load balancer right to the pod in your cluster. And then another feature we launched about a year or so ago is the ability to save money by grouping multiple ingresses under a same ALB. So even if you have applications running in different namespaces, you can have them all fronted by a single application load balancer. And if you can see in the diagram on the right, you have multiple different rules on the ALB that are routing traffic to the different applications in your cluster. The slide earlier, we talked about fewer clusters, lots of clusters. Even at a minimum, you're going to have several clusters for multiple environments. And some of our customers today, you're running tens, hundreds, in some cases maybe thousands of clusters. And so as an administrator, how do you ensure that a fleet of clusters has a consistent set of configuration? And the strong recommendation here that we give to you is to follow a GitOps operational model. By using GitOps, you have that configuration state stored in a central Git repository. And as an administrator, you can commit new configurations, whether that's defining manifests for operational, security, compliance, whatever tooling needs to be on your cluster before you're deploying business logic applications. And then using the Flux operator, which is a GitOps tool, it's natively built into EKS-Cuddle as well, will run in your cluster, notice that the change got picked up in Git, and it'll automatically sync the changes from Git to your cluster. And you can have this running in multiple clusters. And this is the way we recommend to sync and keep in aligned changes from a central place out to multiple clusters that may be in your fleet. How to provision and access AWS services from Kubernetes workloads. One of the projects we're really excited about that we've been working on for the last year now is the AWS controllers for Kubernetes, or ACK for short. And what we heard is customers who are deploying, especially developers, where you're deploying applications in Kubernetes and you're looking for AWS services to support those applications, whether it's an S3 bucket, like is shown in the example here, maybe a database like RDS or Elasticache, or a message queue like SNS. Customers want a consistent way to define both their applications and the resources that's supporting those applications. And so that's what ACK is. You can define your definition for AWS resources in a Kubernetes manifest, deploy a controller to the cluster in this admin namespace, and then in the application namespace, it'll see the controller will see that you have one of these resources defined, and it's responsible for going and creating and maintaining the state of that resource. And so we have lots of services that have controllers already, and many more will be coming next year. Running stateful workloads in EKS takes some special care compared to running stateless workloads. So a stateless workload might be your web server that's just serving web requests, whereas a stateful workload has to store state somewhere. And so for high performance use cases for databases, we have the Elastic Block Store CSI driver. For storage that needs to be shared across pods, we have the Elastic File System CSI driver. If you're running EBS workloads, one of the important points to keep in mind here is that you need to have auto-scaling groups tied to a single availability zone. Because EBS volumes can't move across zones, you might run into a case where a node gets scaled up in a different AZ and the pod gets stuck and can't be moved. So the diagram shown on the right is the recommendation we have for running EBS stateful workloads. And then the last slide here on cluster operations. This is, again, with customers running more and more clusters, one of the questions we get is, how do I discover services running in other clusters? And where you have the central platform team who might be trying to keep the lights on for hundreds of clusters, and the application team who just wants to run their app somewhere, and they don't want to care where their dependent application is running. And one option to do this that's been around for a while is a service mesh. However, a service mesh includes a lot of features such as encryption and traffic shaping, canary, observability, and a lot of customers don't need all of those tools. And so we recently launched a implementation of the Kubernetes Upstream multi-cluster services controller that uses Cloud Map behind the scenes. And it does bidirectional syncing of Kubernetes service definitions across clusters. And so as long as your clusters have network reachability, you can now run application A in cluster A, application B in cluster B, and they don't have to know that they're running across separate clusters. Okay, and the final piece is portability. How do I run consistent Kubernetes across environments? Up until recently, EKS was a product where you deployed on AWS. But we've heard from many of you, whether it's for you have existing costs in data centers on premises, or for various compliance requirements, you need to run certain workloads on premises. How do I get a consistent Kubernetes experience across those environments? And earlier this year, we launched EKS Anywhere, which is our distribution of Kubernetes, the EKS distro, plus opinionated consistent tooling for spinning up Kubernetes clusters on your hardware in your environment. If you still want to use the managed control plane, we also have options for local zones and outposts, which are fully supported by EKS, which lets you keep the fully managed control plane, but reduce latency by putting the compute close to where your customers are and where you need it. So we now offer multiple options for running Kubernetes, from fully managed all the way down to running on your hardware. Okay, now I have all of these clusters running on premises, running in the cloud. How do I see them all in one place? And the EKS connector is a recent launch that enables you to connect any Kubernetes conformant cluster to AWS and visualize it. So if you can see here, I have a COPS cluster running, a local cluster running in my data center, and they're all showing up in the EKS console. So this gives you that single pane of glass for seeing status of all of your clusters. Okay, wrapping up. Where can I learn more? This we covered a lot here, but Kubernetes is a broad space. EKS is always launching new features to make running and managing Kubernetes easier. And one of the strong recommendations I have is for you to go check out the EKS Best Practices Guide, which is our open source guide. We're constantly adding new chapters. There's chapters on security, reliability, a lot of the things we talked about today, but in even more detail. And then where can you give feedback and submit feature requests? One of my favorite places to surf on the web is the containers roadmap. It's our open source roadmap on GitHub. I love interacting with you and hearing your feature requests on there. We look at this super closely as the product team. It really helps us prioritize and gives you the ability to put in your feature requests and let us know what are the most important things that the EKS team can be working on. And that's it. Thank you very much. I hope this was helpful in understanding various features of EKS that can help you run Kubernetes. And thank you.